globe, and specifically in the Indian River Lagoon, provide essential habitat for a variety of organisms, everything from fish, crabs, shrimp, all the way down to sponges, barnacles, and other sessile organisms, or organisms that don't move. So if you come dive in, I can show you some of the cool things that we have on our oyster reefs here at the Indian River Lagoon. So to start, we have our eastern oyster, which are these guys. Eastern oysters are the species that build the oyster reef. So you can see happy, healthy eastern oysters all over the table right now. This is just an oyster shell. So a live eastern oyster has two shells, and all of its muscles and organs and living tissue is inside of those two shells. So this is a whole oyster unit. This is essentially the oyster has died and all that's left is the shell. And then this is an example of a boxed oyster. So this oyster has recently died. There's two shells left. All of the internal organs are gone. But this structure, oysters all join together to form these large reef structures which provide habitat for other creatures. So if we take an even closer look, we can see some of the other life that's on this oyster reef. Down here we have barnacles, which are crustaceans that live a lot of times on pilings, boats, anything that's in the water for long periods of time. So we have lots of barnacles. They're filter feeders, just like oysters are, so they contribute to water quality in the Indian River Lagoon. We also have another type of oyster. This is a different species. This is a flat tree oyster, which grows as part of the reef, but isn't the main reef building species. Our main reef building species is this eastern oyster. But again, this is our flat tree oyster. And on top of our flat tree oyster, we have slipper snails, which is another organism that moves pretty slowly, lives on the reef, and makes the oyster reef its home. If we keep scanning, we have some other fun friends as well. Let's flip over some pieces of the reef and see if we can find any friends. You'll notice as we move the reef pieces around, you can see small critters like mud crabs moving. That's a really tiny mud crab. Let's see what else we can find. More eastern oysters just building on top of each other. Oysters are broadcast spawners, so they spawn. The larvae are planktonic, so they float through the water, and then they eventually find reefs and settle on top of it. So that's how these oysters are all building on top of each other. Let's see if we find. Oh, there's a mud crab right there. See him hiding? Right there, that little guy. So all these reef nooks and crannies are where you can find some really special animals. There's a mussel hidden in that crack. And here's a porcelain crab down here. This is one of the oyster shells from the reef that does not have a live oyster, but these are two oyster spat. So oysters, like I had mentioned before, but we'll mention again, are broadcast spawners. So they release their gametes into the water. They form a larva that floats and is searching for its new home. So what happens is eventually that little oyster larva settles out of the water column and it grows a little foot and it scooches around and looks for a reef to grow on. So these two baby oysters found a reef to grow on, and they begin growing larger and larger, growing their shells, and then turning into this bigger reef unit, all growing on top of each other and together. So that's how reefs make habitat. There's all of these little interstitial spaces where we find our crabs and our shrimp and our fish living amongst all these oysters that start to grow together. The oyster reefs in the Indian River Lagoon, and again, all over the world there's oyster reefs, but particularly ours, play a big role in water quality of the Indian River Lagoon. So eastern oysters, our main reef building species, are filter feeders. So they take in particles and nutrients from the water column and then excrete them as feces and pseudofeces. But what they're doing is pulling those nutrients and particles out of the water column, making the water sometimes more clear, but also just making the water quality better, pulling out some of those nutrients, which are pollutants in aquatic environments. In addition to our eastern oysters, our flat tree oysters also filter water, or filter feeders. Our barnacles are filter feeders, and even our sponges. So we have a little bit of boring sponge here. Sometimes sponges grow on reefs. They're filter feeders as well. So oyster reefs play a huge role as habitat, but they are also helping to clean up and improve our water quality because it's made up of all filter feeding organisms. So that's really important for the estuary at large. Also, oyster reefs provide a food source. So if anybody's eaten oysters, a lot of them come from our coastal states in the US. So in the Indian River Lagoon specifically, we have 3 oyster farms currently, I believe, where you can get fresh oysters from the Indian River Lagoon. So it's a food source for people. And it's not just a food source for people, it's also a food source for the animals living in the ecosystem. So I've seen raccoons forage on oyster reefs, so everything like big mammals. Some fish will chomp on oysters occasionally, so not just a food source for people, but can be very, very important, especially in our coastal cities. So oyster reefs can be intertidal or subtidal, but what happens as intertidal reefs become more and more subtidal or get covered by water more and more frequently, we have an increase in predators and an increase in things that can harm the oysters that live underwater. So for example, here you can see the beginning of a boring sponge. So boring sponges don't necessarily eat oysters, however, they do create holes and compromise the oyster shells. Here is an example of a shell that's been compromised from boring sponge. So you can see all the tiny holes, and eventually the shell becomes very weak and starts to break away from that boring sponge. And boring sponges like to be underwater. So therefore, if our reef spends more time underwater, we have more and more boring sponge interaction, as well as interactions with other oyster predators like oyster drills, crabs, things like that, that like to stay underwater most of the time. We have more and more of those negative interactions. Oysters also can grow faster if they spend more time underwater because they filter feed. When intertidal oyster reefs are exposed, they're not feeding, they're just closed up. So they can grow faster with more time underwater. However, that amount of predators and abundance and interaction with predators is definitely a negative effect of climate change on oyster reefs. Vibrio vulnificus is actually a disease that's found in oysters in the Indian River Lagoon. It doesn't necessarily have a negative impact on oysters, however, it does have negative impacts on human health. So there are a couple different species of bacteria in the genus Vibrio that cause vibriosis. So vibriosis is an infection that causes some pretty awful side effects, including stomach cramping, diarrhea, nausea, vomiting. So essentially, if you eat oysters that have Vibrio bacteria, you can become really sick. Also, Vibrio is found on the outside of sharp oyster shells. So if you get cut by an oyster and Vibrio gets into your bloodstream, it can also cause you to get sick that way. And actually, in some people, it has caused infection so bad that limbs have had to be amputated. So Vibrio is a very serious disease. It's found in oyster reefs naturally. However, with climate change and an increase in water temperature, we expect to see more and more Vibrio in our oyster reefs, and that can lead to more and more infections of Vibrio in people, either by consuming raw oysters or getting cut by oysters in the Indian River Lagoon. So again, this increase in Vibrio is going to be from our increases in temperature, which help that bacteria to thrive, which is not so great for us humans and our health. Oreoumbra lagunensis is known as brown tide. You all may have heard of brown tide in the Indian River Lagoon. It's a marine microalgae that has caused some of our large-scale harmful algal blooms in the northern Indian River Lagoon. This species of microalgae has caused major ecological shifts and some pretty major fish kills, so not great for the health of the lagoon. Oysters and other bivalves have been known to be able to consume some amounts of Oreoumbra. However, when there are large amounts of this microalgae in the lagoon, oysters can have trouble keeping up, and it shows a negative impact on that spat or baby oyster recruitment. So this brown tide doesn't seem to have a negative effect on human health, but we do see it having a negative effect on our ecosystem at large and on our oyster reefs. in sort of limiting that baby oyster or spat recruitment. And we are seeing more and more brown tide balloons in the Indian River Lagoon as climate change increases. So in 30 years, in 2050, we expect to see more and more harmful algal blooms with the increase in rain runoff and the increase in temperature. Those are two things together that can cause a lot more algal blooms, which we have trouble with in the Indian River Lagoon today. So we're just going to see more and more of that negative impact, especially on these reefs. So in around 2050, 30 years from now, we expect coastal acidification to increase. So coastal acidification is when the pH of water becomes more acidic, and this is happening due to climate change. There are several chemical reactions that take place, but instead of diving into that, we're just going to talk about the effects that we know the coastal acidification has on oyster reefs. So you see all these compromised shells that are sort of broken apart and weak. Here's a boxed oyster, so the shells are degrading. This shell degradation can be caused by coastal acidification. So as the water becomes more acidic and the pH gets lower, our shells begin to be compromised. So mollusk shells are made out of aragonite, which is susceptible to degrading in acidic water. Meanwhile, crustaceans, their shells are a little bit different, or their bodies are a little bit different, so they're not as compromised by acidification. But specifically oysters, they don't do well as water gets more and more acidic. So climate change is also causing the reef structure itself, the actual eastern oysters, to begin to degrade. And we expect this to continue over time. We're gonna see less and less spat, because it specifically affects small and young oysters even more. But we'll also see some degrading in adult oysters. But specifically when these little guys, these spat, try to come to the oyster reef, they have a really hard time growing their shells as our water acidity increases. So ocean acidification, and specifically coastal acidification, which is happening in some places at a faster rate, is a really, really bad sign for our oyster reefs, which will have way more trouble forming our reef habitat, which is essential for the lagoon. So these are red mangrove crop roots. In the Indian River Lagoon, we have 3 species of mangroves: red mangroves, white mangroves, and black mangroves. And they're found throughout the whole Indian River Lagoon system. Mangroves are a protected habitat, they're really important. However, as climate change increases, so does the range of mangroves. In the northern Indian River Lagoon, specifically Mosquito Lagoon, we haven't had too many mangroves in recent history. Most of them are found in the middle and southern Indian River Lagoon, but as climate change continues in the next 30 years, we expect to see more and more mangroves in Mosquito Lagoon starting to grow on top of our oyster reefs. So as climate change continues and temperatures get warmer consistently, we'll see these mangroves moving further and further north, and we're going to start to see more interactions of mangroves growing on top of oyster reefs like you can see here. So as climate change continues over the next 30 years into our years of 2050, we expect to see more and more intense storm activity. So that includes hurricanes and just other more intense storm events. And with those storm events come waves. Our oyster reefs can put up with wave energy. They protect our coast, but only to a certain point. So if we're having more and more intense storms, you can see the negative impact it's having on our reef. Our reef is becoming disarticulated, so the shells are separating. It's not as strong as a reef, and it's not blocking as much wave energy as it was before. So our increased storm events and increased waves also are going to have a negative impact on our oyster reefs in the next 30 years and as climate change continues. Thankfully, we can change the tide of climate change through small actions in our lives that can have ripple effects to positively impact our communities, our nation, and the world at large. We can conserve water, so little things. If you're brushing your teeth, shut off the water. Try to water your grass less if your parents own a home or you live somewhere where that's an option. Little things, every little thing adds up, especially if we're all doing it together. So conserving water is really important because it sends less gray water and black water into our watershed, which ultimately ends up in the Indian River Lagoon if you live in eastern central Florida. We can also promote and participate in lagoon-friendly landscaping. So if your parents or someone you know owns property, you have a yard, you can plant Florida native or Florida friendly plants to help reduce the amount of irrigation. So again, lessening the amount of water entering the watershed, and also avoiding using chemicals like pesticides and fertilizers in your lawn, which ultimately, if you live within the lagoon watershed, make their way to the Indian River Lagoon. We can also lessen our carbon footprint. So things like carpooling, riding your bike, taking public transportation if it's available, shutting off lights when you leave a room, just trying to reduce our energy consumption to try to reduce our use and dependence on fossil fuels. And the most important thing you can do is make your voice heard. Tell people, spread the knowledge that you have. Not everyone knows about climate change. Not everybody understands the negative impacts of climate change and global warming. So if you can be the one to bring awareness to people and advocate for a better future, that's the most important thing you can possibly do, is spread the word, make your voice heard, and again, try to just create some small ripple effects throughout your community that can positively impact our reefs and positively impact our world.